Hello, ladies and gentlemen. Welcome to today's video. Today we will focus on acid and bases. So in this chapter, the thing that we will master are define acid and base, and of course, what is alkali. Second, we will learn the chemical properties for acid and base. And then number three, strength of acid and alkalis. And at last, we will learn indicators for them. So first of all, what is acid? Acid, in our IG syllabus, you need to be familiar with a few acid, which is HCl, hydrochloric acid, nitric acid, and sulfuric acid. So all these three acids are the strong acids that we'll learn in year 10. And then in year 11, we'll learn some organic chemistry we will learn at that time. So can you see, all of these, they actually start with H, which means they're able to ionize and form hydrogen ion. So what is hydrogen ion? For hydrogen atom, we know that is H11, which means each atom of hydrogen contains one proton, one electron, and actually no neutron. If this hydrogen atom, it lose electron, so it will left proton. That's why we also mention hydrogen ion as proton. So if it release out hydrogen ion, so we can also say them as proton donor. They donate out the proton. This is the definition for acid. Then how about base? Base is reversely is the substance that can accept proton, which hydrogen ion will be received by them. So that's the first thing. Second thing, base include any metals that is oxides or hydroxides. So after we learn base, what is the relationship between alkali and base? We need to know base contain all oxides or hydroxides metal. Out of this base, there are some base that are able to dissolve in water, form alkali. For example, sodium hydroxide, potassium hydroxide, and ammonia. All of these are able to dissolve in water, then we call them alkali. Okay, so after familiar with the idea, we can go for IG's question. Solid sodium hydroxide is a base which dissolves to form aqueous solution. So what is the mean by terms of base? In IGs, we always need to talk about proton. Base is a proton acceptor. Next, state the term given to base when it dissolves to form aqueous solution. We call this part alkali. Next, ethanoic acid react with water to produce acidic solution. Which role describe the role of ethanoic acid? So ethanoic acid is acid. So acid proton donor. And then the one that will react with the acids is actually accepting the proton. So it's C. Next, ammonia react with water to form ions. How does this equation show ammonia behave as a base? So we know base accepting a proton. It's a proton acceptor. That's why it acts as a base. Then it says ammonia is a weak base. So we know that the pH 1 to 6 is acid, 7 is neutral, and then 8 to 14 alkali. So if it's a weak base, means that it's in this range. So any numbers from 8, 9, 10, 11 will be accepted. Next question. In which equation is the underlying reactant act as a base? Base means it's accepting hydrogen ion, proton. So this lose proton donor. So this act as acid. This also lose proton or proton donor, so it's also act as acid. Here it's proton acceptor, so it act as base. Next question. Chloric acid is a strong acid. It can make from calcium chloride. So define acid as a proton transfer, so this is a proton donor. Next, complete the chemical equation to show that this act as an acid. Means that it will donate the proton, so it will left this part which negative charge, because here positive, here confirm is negative. Then this proton will receive by this H2O, become H3O plus. Next, we go to the second part, which is what are the chemical properties of acids alkali. We go for acids first. Acid will always react with three types of things, which first, it reacts with base, which include alkali also, and this process we call them neutralization. Second, acid will react with metal, except inert metal, which is not that reactive compared to hydrogen, which is CuAgAu. Third, acid will react with carbonate metal, Let's see some example. Acid and base. The acid that we know is HCl, and then the base, let's say, is NaOH, which is one of the alkali. So HCl, it will form H plus and Cl minus. NaOH will form Na plus and OH minus. When they are having reaction, hydrogen ion and hydroxide ion, they will always form water. How about the sodium and chloride? So positive and negative, they will join together. So the positive metal ion and negative non-metal ion, when they combine, they will form salt. So as general, acid plus base, it will form salt and water. Let's try one more question. For example, HCl plus another base, for example, magnesium oxides. HCl will form H plus and Cl minus, Mg2 plus and O2 minus. So we know whenever we have H and O, it will form H2O. Then the positive metal ion and non-metal negative ion will join together. The chloride part need to double, so the charge will balance, and then we need to do balancing. Here mass times 2. So this is the balance equation. Again, it will form salt, and this is a water. Just like this for all neutralization situation. Second equation is acid will react with metal. For example, nitric acid react with magnesium. It will form H plus nitrate, Mg2 plus. So we know that the positive metal ion will combine with the non-metal anion. So it will form MgNO3. Because here is 2 plus, here is 1 minus, that's why here need to times 2. Then this hydrogen, it do not have O or OH to react with it. So that's why the H can only react back with themselves. So we will form hydrogen gas. So we do balancing. So that's why all acid plus metal, it will form salt and hydrogen gas. We try one more example. Let's say H2SO4 react with zinc. H plus SO4 2 minus, it's like N2 plus. So metal ion and non-metal ion will form zinc sulfate and then left hydrogen. This equation is already balanced, so it will form salt and hydrogen gas. Let's talk about acid and carbonate metal. Let's say I use HCl plus CaCO3, H plus and Cl minus, Ca2 plus and carbonate ion. And you always need to remember carbonate ion, it will form CO2 and O2 minus. H and O will confirm form H2O. And then CO2 is just carbon dioxide gas. And then the metal ion will combine with the non-metal anion to form CaCl2. Because 2 plus and minus, so that's why the negative charge need to times 2. Then we do balancing. So for all acid and carbonate metals, it will form a salt, carbon dioxide, and water. So make sure you are familiar with these three. Okay, so let's see the question. A small volume of aqueous P is poured into solid Q, tap of the funnel closed, which pairs of substance cause a string to fill with gas, which means it must produce gas. And just now we already learned acid plus base, no gas will form because it's just water and salt. Acid plus metal, it will form hydrogen gas. Acid plus carbonate metal will form CO2 gas. So acid react with metal, it will form hydrogen gas. So correct. Acid react with metal, looks like correct, but can you see? It can react with metal except the inert metal, which is a CuAgAu. They can't react because CuAgAu is not reactive. So that's why it can't react. So no gas are released. Last, acid and carbonate metal, it will form CO2. Yes. So the answer is C. Next question. Name 2 compounds, each of which react with dilute sulfuric acid to produce aqueous zinc sulfate. So we know that to make it zinc sulfate, the sulfate can be produced by this H2SO4. We need to add something with zinc, but we can't write it as zinc because zinc is not a compound, zinc is an element. So it's either a base zinc or a carbonate metal zinc, zinc carbonate. Base zinc can be zinc oxides. The question requires for name, so we just write zinc carbonate, zinc oxide. Next question. Which statement about aqueous ethynyl acid is correct? It reacts with magnesium. So acid react with metal can produce salt and hydrogen is correct. It reacts with NaOH, produce salt and hydrogen. NaOH is a base, so it will form salt and water. Next, it reacts with ammonium salts to produce ammonia. Okay, so this thing we will learn it's alkali reaction. And then it turns litmus paper blue. So we will learn at last the indicator, acid will turns it red. Answer is A. Next, NaOH react with H2SO4. Which type of reaction is this? So acid and alkali, it's neutralization. Next, NaOH, so it will form Na plus, OH minus, H2SO4, H plus SO4, 2 minus. So as long as I have OH and H, it will form H2O. And then Na will react with SO4, so we will form Na2SO4 because the positive charge is lesser, so we need to double the sodium, then it's balanced in charge. Next, phosphine has a similar chemical structure to ammonia. Ammonia acts as a base, react with H2SO4. So what is the term's base we learned just now? It's a proton acceptor. Write a chemical equation for the reaction between ammonia and sulfuric acid. So NH3, H2SO4. Since ammonia is a proton acceptor, so it will form NH4 positive charge. So NH3 and H plus form NH4 ammonium ion, positive charge, negative charge. So this part we need to double it. So we form NH4 2 SO4. Balance the equation. Okay, copper nitrate can be made by reacting copper carbonate with nitric acid, and then it will produce CO2. So write the chemical equation. Copper carbonate, it reacts with nitric acid. Carbonate ion will form CO2 and O2 minus. And then here will form H plus and nitric ion. CO2, O react with H to form H2O. Metal ion and non-metal ion will join together to form Cu and O3, 2. Now we do balancing, so we'll get a correct answer. Okay, after familiar with the 3 chemical properties of acids, now we go to the 2 chemical properties of alkalis. So the first chemical properties is exactly the same as acid because acid plus alkali will form salt and water. So for this part, it's the same, no need to learn again. So next part is the new thing, which alkali will react with ammonium salt. What is the meaning of ammonium? So it's contain this cation. This cation can be with any anion, for example, ammonium chloride, ammonium sulfide, ammonium nitrate. So all the ammonium ion salt, when it reacts with alkali, what will happen? So let's say we are using NaOH, react with NH4Cl. If you're not very familiar, we always separate it into different ions. NaOH is Na plus, OH minus. Here we form NH4 plus and Cl minus. Ammonium ion further split to ammonia gas and hydrogen ion. So after it split, can you see is alkali plus acid. So H and OH will form H2O. And then metal cation will react with non-metal anion, so from NaCl. And then of course, the ammonia will be released. So this is the thing that will form when alkali react with ammonium salts. So it's very similar to neutralization, just that this will form ammonia also. So Na plus OH, NH4 plus Cl. So this will further speak to ammonia gas and H plus. So this and this will react, become water. This is ammonia. Sodium and chloride will form sodium chloride. Which statement about acid and base are correct? Acid react with metal to give hydrogen. Yes. Next, a base react with ammonium salt to give ammonia. Yes. Acid will react with carbonate metals to give out carbon dioxide. Yes. Alkaline solutions are orange in methyl orange. No. Later we will learn in indicators. Methyl orange, this orange represent the neutral state. So the answer is 1, 2, 3. Next, we go to the third part, which how to see the strength of acid or alkali. So for acid and alkali, it's either in strong situation or weak situation. So how can we differentiate them? Strong acid or alkali, it can 100% dissociate. For example, HCl. If we dissolve it in a solution, it will 100% form hydrogen ion and chloride ion. This will only happen when we dissolve it in a solution. So since it's 100%, so we only one direction arrow to show that fully 100% it forms H plus and Cl minus. How about a weak acid? It will only partially dissociate. For example, HCOOH, methanoic acid that we will learn in organic chemistry. So since it's not fully 100% dissociate, so we cannot draw one direction arrow. We must draw reverse direction arrow. This hydrogen for organic chemistry will form the hydrogen ion, and then the balance HCOO will form the negative ion. Same goes to alkali. For example, NaOH, when we dissolve it in solution, so it will fully form Na plus and OH minus. Then how about partially dissociate weak alkali situation? For example, NH3 plus H2O, it will have reverse direction, so it will form NH4 plus and OH minus. Let's see the question. Sulfuric acid is a strong acid. So what is the meaning of strong and acid? Strong means 100% dissociate in solution, and then acid is a proton donor. Next, which statement about aqueous weak acids is correct? So weak acids are always dilute aqueous solution. It's not necessary. For example, the organic acid, you can put very concentrate, just that it's still weak because it do not fully dissociate. Weak acid dissociate fully? No. Weak acid partially dissociate. When a weak acid is added to blue litmus paper, it stays blue. No, acid is always turns it to red. We'll learn in the last part. When a weak acid is added to magnesium, aphorisms, yes, because no matter it's strong acid, weak acid, it will still react with metal to form hydrogen gas. So answer is D. Next, what is definition for strong acids? Acids is proton donor. Strong means completely dissociate, 100% dissociate. So answer is C. Four statement about strong acid are listed. They say they react with carbonates to form carbon dioxide. It's always correct for all acids. They completely dissociate in aqueous solution. Yes, this is for strong. They react with ammonium salts to form ammonia. No, this is for alkali. They are proton acceptor. No, acids are proton donor. So answer is A. Which statement about acid is correct? That says weak acid partially dissociate. Correct. Acid accepts proton. Oh no, acid is proton donor. Ethanoic acids acts as a strong acid. No, all organic acids are weak. Hydrochloric acid is strong acid. Correct. That's ionized in water to form hydrogen negative ion. Is kidding. Is hydrogen ion, which is proton ion. So answer is A. A sample of ethanoic acids and hydrochloric acids have the same concentration. How do the hydrogen ion concentration and pH of ethanoic acids? Okay, so ethanoic acids is a weaker acid. pH 1 to pH 6 are acids. pH 1 is the strongest. If ethanoic acid is a weaker acid, so the pH value will be more than 1. pH value will be slightly higher. So how about the hydrogen ion concentration? Ethanoic acid partially dissociates, means that the hydrogen ion is not 100%, it's less than 100%. So answer is C. Next, statement about 4 different acids are listed. You have this amount of HCl, pH is 2. You have the same concentration of ethanoic acid, but the pH is higher. So we also have hydrobromic acid, which is a strong acid. Ethanoic acid, which is slightly stronger acid. What are the pH value of the same concentration of HBr and trimethyl ethanoic acids? So the pH HBr, they say HBr is a strong acid. Strong acid must be lower. Ethanoic acid is slightly stronger. So this is slightly stronger than trimethyl ethanoic acid. So trimethyl ethanoic acid is slightly weaker. So the value will be slightly above. So answer is B. Next. Ethanoic acid is the weak acid. So 1 is the strongest, 6 is the weaker. So as long as you give me anything from 3, 4, 5, 6 is okay. So let's say I choose 5. Complete the symbol equation for the dissociation of ethanoic acid. So we'll dissociate and form hydrogen ion, and then the balance part will be negative. And remember, it's a reverse reaction because it's partially dissociation. Next, which solution have the lowest pH, which is the strongest acid? So must be acid. This is weak acid, this is strong acid. So answer is donkey. Next, ethanoic acid is weak, hydrochloric acid is strong. Okay, so this says ethanoic acids are partially dissociate. Yes, weak acid partially dissociate. And then this concentration of ethanoic acid have higher pH. Higher pH means weaker than this. Oh, yes, correct. Ethanoic acid is always more dilute. No, it's just weak. It doesn't matter whether it's dilute or concentrated. Ethanoic acid is a proton acceptor. No, all acids are proton donor. So answer is A. Last, we go to the indicator of acid and alkalis. So there are three very famous indicators that you must know. Methyl orange. So methyl orange and litmus both will show red color in acids. So this thing you can remember together. And then methyl orange, the orange represent the neutral color. Next, the alkali situation, the color will be lighter and lighter. So it will form yellow. For litmus, we already know, in alkalis, it will blue. Time of toluene is the new indicator. Long time ago, we are using phenolphthalein, which shows pink color in alkalis. So time of toluene will show blue color in alkalis. When neutralization titration method, we always use time of toluene. So we put it in alkali, so you see a blue solution. So how can we confirm the titration is completed? When blue color change to colorless. So make sure you're familiar with all these three. The first question, see the color of time of toluene in alkali. Time of toluene in alkali is blue. In acid is colorless. Next, sodium reacts vigorously with water to form NaOH, which is a strong base. Explained in terms of proton transfer, base is just a proton acceptor. See the pH that indicates strong alkali. Strong alkali is the maximum, which is 14. See the color of methyl orange in NaOH. It's red color for acid, orange color for neutral, and then yellow for alkali. What is the characteristic of acid? Acid turns methyl orange into red. Acid have high pH value. No, it's just 1 to 6. Okay, high pH value is alkali. Acid react with ammonium salts to form no. Ammonium salts react with alkali to form ammonia gas. Acid react with carbonates to produce salt and water and carbon dioxide. So D is the only correct answer. Next, acid are important lab chemicals. So some acid completely dissociate. See the term applied to acid that completely dissociate, strong acid. Complete the equation to show the complete dissociation. It will donate out a hydrogen ion, 2 hydrogen ion per H2SO4. See the color of methyl orange in acid is just red. Next, dilute sulfuric acid and NaOH is used to prepare sodium sulfate crystal by using titration method. So it's just why universal indicator is not suitable for this titration. So this is the pH scale for universal indicator. Can you see? The color keep changing. So because too many color changes, so it's not accurate for titration to confirm that which specific point is just nice for neutralization to happen. So because too many color change. Name an indicator that can be used in this titration. Normally, we will use time of toluene. You also can use methyl orange. Next, a few drops of methyl orange are added to reaction. During this reaction, a gas is produced and methyl orange change red to orange, means that it's from acid to neutral, and then it produces gas. So it's either produce hydrogen or carbon dioxide. Confirm not alkali because it's initially red in color. Confirm acid. It can react with magnesium to form hydrogen gas. If it reacts with alkali, it will form salt and water only. No gas are released. So that's why answer should be C. Next, potassium hydroxide is a base. Which statement describes reaction of potassium hydroxide? Chlorine is formed when it's heated with ammonium chloride. KOH plus NH4Cl. So it will form HCl plus H2O and ammonia. So it won't form chlorine. Next, isn't universal indicator green? No. It reacts with an acid to produce salt and water. Yes, acid and alkali will form salt and water. It turns methyl orange red. No, methyl orange will turn yellow when it is alkali. Okay, it's just like this for acid and bases in IGCSE. So don't forget to subscribe, like, and share my YouTube channel. If you have any question, please comment here. See you in the next class. Bye-bye.